Quantum computers promise to solve problems that today's most powerful supercomputers could never touch. But there's one big problem. Qubits, the building blocks of quantum computing, are fragile, unstable, and error-prone. Now, a surprising mathematical revival has revealed a class of overlooked particles with a catchy name, Neglectons. And they just might be the missing piece to unlock the full power of quantum computing. To understand why Neglectons matter, let's start with the problem. Qubits can exist in superposition, meaning they represent both 0 and 1 at the same time. This makes quantum computers powerful, like solving a giant maze by walking every path at once. But there's a catch. Qubits are extremely fragile. Interactions with the environment, heat, noise, even cosmic rays, can collapse them instantly, leading to errors. That fragility has made building large-scale, stable quantum computers one of the greatest challenges in modern science. One of the most promising ideas comes from exotic particles called anyones, which only exist in 2 dimensions. Unlike normal particles, anyones don't store information in themselves but in how they braid around each other. Imagine tying knots in a rope. The pattern itself is the information. This kind of encoding makes anyones naturally resistant to noise, and among them, Ising anyones have been the star candidates for building topological quantum computers. But there's a problem. Ising anyones aren't universal. It's like having a computer keyboard with only half the letters. Powerful, but incomplete. And this is where mathematicians made a breakthrough. For decades, physicists used a theory called topological quantum field theory to study particle symmetry. In that theory, some particles were assigned a quantum dimension of 0. With 0 weight, they were thrown out as irrelevant. But a team led by Aaron Lauda at USC revisited these so-called useless components. By applying a new mathematical lens called non-semi-simple topological quantum field theory, they found a way to reinterpret these zero-weight objects as real active quasi-particles. They named them Neglectons. And here's the kicker. When combined with Ising anyones, Neglectons fill in the missing pieces. Think of it like this. Ising anyones gave us half the alphabet. Add Neglectons, and suddenly you've got the full keyboard. That means, in principle, you could build a fault-tolerant universal quantum computer using these particles alone, without needing extra error correction overhead or exotic new materials. If Neglectons can be realized in real systems, they could revolutionize quantum computing. From drug discovery to climate modeling to breaking uncrackable codes, the applications are staggering. And now, thanks to a once neglected piece of math, we may have just taken a giant step closer to making it real.